galaxies today. They were not knowing that much. Today we know the way. Your initiatives are going to really make a big change in the minds of young people. Congratulations to for your vision, education, commitment to help the students to come up in their life.
Welcome.
So, are you happy? Coming here and listening to me? Okay, great. So, I was told to listen to your question and give answers. But then before I do that, I thought I will speak a little bit about the space. Is it good? Okay. So if you agree, then I will talk about Indian space odyssey and vision a little bit. There are nothing to read, only visuals are there. You can just look at the visuals and then understand what we have done in space. Okay? But you would have already read something about space program. Have you? Otherwise, you can go to the next slide. Somebody can help me. Okay. See, if you really look at our space program, we have done 200 plus missions. You know, when we started our space program, which year we started? 1969. Excellent. I think congratulations to you. But then when we were doing that and sending small rockets, Americans were already on the moon, you know, and we were doing small rockets. In the last so many years, we have built our own rockets, our own satellites, and we have landed on the southern part of the moon today. We are the first country to do that, no? So last 60 years, we have done so much in terms of building rockets, satellites, and missions. And you look at that, 431 satellites of 34 other countries we have launched. That kind of satellites we are launching using our own rockets. Is it a great thing? Definitely it is. So I am not going to describe all these things, rockets, satellites. So of course you would have known the names. There are some displays outside. Don't forget to look at all of that displays after you go. Okay. So now, if you can help someone help me moving to the next slide. Okay. You look at the launch. Look at the LVM rocket taking off. Anytime have you seen the rocket launch? Only in video or TV or really? No. What I will tell you is you should come to Sri N.S.Bosaraju. Okay? You should all come to Sri N.S.Bosaraju and watch a launch directly. And we have made all arrangements for you if you come. There is a vast gallery where 10,000 people can sit and watch a launch. What is that? You didn't hear any sound now, no? But the sound there is really great. You will feel it vibrating. The earth is vibrating. The roar of the rocket going. You can actually see it going up. That is an exciting feeling. So for that feeling, I want you to come to Sri N.S.Bosaraju and watch it. Will you come? And you tell your schools, select some of you, but all of you cannot travel. 2,000 people traveling to Sri N.S.Bosaraju and looking at it is difficult. But then you will find some way to select them and then take you to Sri N.S.Bosaraju. Please come there. Okay? I think it's a very great opportunity. And not only see the rocket launch, but also you can see the facilities, what we have built. Beautiful facilities, international facilities, how we are making rockets, how we are integrating rockets. Sometimes the rockets we can go very close and touch it also. Okay? And today, I know there are 3 rockets being assembled in Space Center, Sri N.S.Bosaraju. Go and see it. You will really get. And you can see some of these rockets. Today, you know the PSLV. Have you heard about PSLV? You know the full form. You know the SSLV, the LVM3, and we are developing a new rocket called NGLV, the next generation launch vehicle. It's a massive rocket. It can take 30 tons to space. 30 tons. You know how many mass it is? That much of satellite we can take it to space. So we are developing all these rockets in India. But then, next slide please. Yeah. But the most important thing I want to tell you is the work that we are doing in Gaganyaan. Gaganyaan, you know, program? Human space program. We want to send Indians to space. And that is using this rocket LVM3. In the space capsule, we will put them and take them to space and bring back safely to land in the sea. But before doing it, we have to do so many missions. And when they send a human to space, unlike satellite, you need to be very, very careful. Because our human life is so precious. So you need to do a lot of care to make the engineering should be correct. There shall be no accident. Their life should not be lost. and they should be able to come back without having any injury also. So we are taking a lot of design work, a lot of testing is going on. And the first launch called G1, where we are going to put a robot, a Vyomitra. Have you seen the photo of the Vyomitra? Anyone who has seen? Vyomitra, our robot, the lady robot that is going to go to the space. Anyone has seen the photo? No, I think you should see that. And that will speak to you in your language. If you ask a question, it will answer. It will help you to do some switches. It will operate this with his hand. It has a 5 finger, 2 hands. But unfortunately, only up to this. It doesn't have legs to walk. Okay. So right now we are only at that much. And that robot will go in this mission and will do the testing. But I can guarantee you someday we will have a full-fledged Vyomitra who is walking, will go to space. Right? Like human beings. But this is a very important work which we are doing. Human spaceflight program. Please read about it and understand why it is important to send humans to space. Why robots cannot do all work? Do you think the robot can do everything and human cannot do everything? Which one is better? Human is better or robot is better? Why? Why human beings are better and robots are not that better? Because we have some sense which robots cannot have. Robots can do only what it is taught, but you can do beyond what you are taught. You can think about it, you can look at what will happen if you do something. You have something called a special intelligence, which many of the robots are not having. But I can tell you, artificial intelligence is so much around, and slowly the robot will become much better and better and better. One day, they will surpass you if you do not learn very well in school. Okay? Okay, so let me go to the next slide. But another important work which you are doing, looking like space planes. Have you seen space shuttle? Which is the Indian astronaut that travel in a space shuttle? Rakeshkumar did it. Rakeshkumar went in the Russian craft, Kalpana Chawla. So, but then she met with a difficulty. But that space shuttle is not flying. But today, every nation is developing space shuttle-like crafts, but they are not manned. They are going to be autonomous. There will be no human beings, and computer will control and make it land. And that type of crafts we are developing in India, and you can see that next. Next slide. Yeah, you look at it. Our RLV, reusable launch vehicle, coming and landing in Chitradurga. There is a runway near to Chitradurga where we did this experiment. Our reusable craft coming and landing. It is fully controlled by computer, and this test was done by dropping a craft from a helicopter and coming and landing precisely on the runway. And even if it is deviated, it will still know how to come back and land using its own sensors, cameras, altimeters, and many other complex devices. And we want to send it to orbit and bring it back. And this is very important for us to send automated devices, spacecraft, surveillance equipment, etc. to space and do work on this. So it's another interesting area that we are working. Next slide. Yeah, look at the picture, beautiful picture of its landing, fully autonomous, and it can go to space also, it can come back. Okay, next slide. Now, very important topic I want to discuss with you is Chandrayaan 3. I think all of you know about Chandrayaan 3 landing, successful landing on the southern side of the moon. But you know about Chandrayaan 1 and 2? I hope you know. Now, Chandrayaan 1 was launched in 2007, 2008, and Chandrayaan 1 found out very important outcome. The water on the moon was found out by Chandrayaan 1. And Chandrayaan 2 was the attempt to land on the moon, soft land on the moon, but Chandrayaan 2 produced also great outcome. But Chandrayaan 3 is the most important thing because it achieved the soft landing on the moon. Go to the next one. I tell you, the Chandrayaan, this one, have you watched live? How many of you watched live on August 23, 2023 when this was happening? The soft landing on the moon was happening and all of us very jubilant at the control center and looking at the landing of the moon. I think it was a historic event for all of us. And all the people who contributed to work were very, very happy to see it landing on the moon at the southern side, precisely. And not only that, it landed on the moon. Next slide. That it found out many, many things later. And this is about Chandrayaan 1, finding water on the moon. And you know, Americans were and Russians were going to moon in 1960s, but nobody found out there is water on the moon. And we have to send a craft in 2008 to find there is water on the moon. Today we know possibly there is water, maybe subsurface water is there, here you can go and take it and then leave possibly. I do not know, maybe future moon missions will find out. But go to the next one. And this is a Chandrayaan 2 mission where we send fantastic cameras. Today, the best picture that is available from moon, about moon, is from our own camera. 25 centimeters resolution. The entire moon is imaged today, and our images are used by NASA and Japan and many others for their moon missions. We supply them images. You just imagine. Now that is a change that we have brought. We have our own capability to help others to get in. I think we should be very proud of it. But Chandrayaan-3 is the one which landed softly, and our rover Pragyan moved around almost 100 meters on the surface of the moon. We did a lot of experiments to find out what is the minerals on the surface, and all the 5 experiments produced beautiful results. But you know, it survived only 14 days. Why 14 days? Can anyone tell? Because one day on moon is equal to 14 days on Earth. And then there will be night, which is again another 14 days. So when that night comes, the temperature goes down so less and nothing will survive. Electronics, battery, everything goes back. And we couldn't get back the craft back later. But I can guarantee you subsequent missions to moon, we will make sure that you work for days together. We need some new technology for doing it to produce power. We cannot depend on sun alone. We need other technologies like fuel cells or nuclear fuel, etc. to help us generate power. And we will be putting it in the future missions. Okay? So you can look at the picture that was there earlier. That was a classic image. It's there in the book also. The image taken by Chandrayaan-3, the rover took the image of the lander. And this is a very classic image. And if this picture was not there, all of you would have asked, no, we don't believe you. You are not landed on the moon. Today, looking at the picture, can you tell we did not go? You are sure now? Yeah, good. Okay, next picture. Next one. Yeah. You see this picture, can anyone tell what it is? Mars. And look at the image, such a beautiful image, 3D image of Mars. You know, this is taken by our cameras using the Mars orbital mission. MOM did that image. Today, the best of the image of Mars, called Mars Atlas, is done by our own satellite, the Mars orbital mission. It's still one of the best satellites that we ever launched. And there are a lot of scientific findings from going to Mars. And I can tell you, India is the very first country ever to go first mission and become successful. Everyone in the first mission last year. And how many of you know about Aditya? Anyone? Yeah, a lot of you know about it. What is going to find out? It's study about the sun. Sun is very important for us because all our energy, the light, the energy, that food we eat, everything comes from there. The energy comes from there. And there are a lot of issues in sun. There are periodic variations, there are some activity, there is something called space weather. It affects communication, it affects networks, it affects traffic in space, etc. And it has so much importance to future. So we send this satellite to a point called Lagrangian point, and will stay there and look at sun continuously and take images of it. Using sort of how many instruments? There are 8 instruments on board this Aditya L1. You know, this point is 3 times the distance of moon from Earth, and we put it there precisely. I think this is a great achievement for our scientists to make this travel that much far and be there. And it will not never go away, it will remain there forever until the satellite works. It's a great outcome out of Aditya L1. Next one, please. So today I can tell you, dear students, we are having 50 plus satellites in space, various types of satellites, communication satellites, remote sensing satellites, navigation satellites, and science satellites. So we have 50 satellites in orbit, and all of them are controlled using facilities in Bangalore. This track, we have a control center, we have a facility at Hassan, which controls the communication satellites, and all of them are controlled using, not even, they are not controlled like a car, we don't have to have driver here. Everything is done by computer, it looks at it, it is doing its function autonomously, and if any problem is there, we have to alert the people on the ground, and then only we need to work on it. So otherwise it works everything automatically. So you can go and see some of the control centers, look at the antennas. It's all in Karnataka only. So one day you should take a trip to Hassan, see our control facility and see the huge antenna we have built. So some of this you can arrange to. You don't have to go to Shah to see, but to see rockets, you need to go to Sri N.S.Bosaraju. Okay, next slide. Yeah, we built a lot of satellites in other nations. One of them is NASA, ISRO Synthetic Aperture Radar. It is the costliest ever satellite that we have built. And this launch will take place possibly next year beginning. And this is going to be NASA, people are already working with us. Can you imagine that NASA people coming and working along with ISRO people to build the satellite? Earlier we were all thinking that we'll go to NASA and build so many things. Today the times have changed. We have confidence to build satellites together with NASA. And they are happy to work with us and build satellites. One of the costliest ever satellites that Americans are building along with India. And you look at the other satellite we are building is with the French national agency, CNES. CNES is the French National Space Agency, and we are building a satellite called Krishna. It's a thermal imager of Earth, and you can look at Earth in this lies a heat or a radiating object. So we can find out climate change and related issues using the satellite. And NISA will take the images of Earth every 12 days. So it's such a very important satellite for us. Next one. We are also building satellite called G20 satellite. So this is the first time that India is going to build satellites for other nations on a collaborative manner. Have you heard of G20 nations? So 20 nations have come together to form this group, and this group is going to build the satellite for all of us, and we are hosting the payloads in our satellite, and we started building the satellite. Next one. So we are also building a satellite called SpaceX, and this launch is going to take place in December 20th. And this satellite, 2 satellites we are launching, and they will go 20 kilometers apart in space, come back and connect using docking system. You know, docking is important, no? If you want to go to human space flight, you want to go to space station, you need to travel to space and go and attach to space station, and people have to pass through with the ceiling. So if you have to do that, we need to have this technology. To prove this technology, the satellites are ready. Just now, one private company in Bangalore has built it for us, and we have taken to Sri maybe possibly in another 20 days, and launch will happen in December itself. And this is going to demonstrate one of the important critical technology of docking. We are also building satellites for TDS-01. We will have electric propulsion. First time using a propulsion, using the energy of sun, we are going to move the satellite propulsion wise, not using chemicals. So this is another important satellite that we are building. Next one. We are building satellites for quantum communication. Heard of quantum communication? How many of you have heard of quantum communication? At least a word? Not much. I think I will tell you quantum communication is another emerging area, and possibly when you become little more older, go into higher studies, you will be using quantum technologies. Very important for all of you, especially in computers. All the computers are going to change in the future. Very fast computing will happen, and quantum communication will come where you will have a lot of security. Nobody can peek into what you are talking, and all these are important for you in the future. And we have already started building quantum satellite to do encryption for communication. Very important area. We are also building satellites for software-defined satellites, which you can totally program from ground. So next one. We have a system called NavIC. Heard of NavIC? Have you heard of GPS? Where is GPS? In your mobile system there? Where is GPS used in your mobile? Anyone tell? Yeah, when you look at traveling from one place to another, there is a GPS tracking, no? And who is the owner of GPS? Who owns GPS? It is owned by America. Do you know that India got a similar equivalent to that? That is called NavIC. So India has a service called NavIC, and it can be used in mobile phones, cars, and tracking devices. It is not yet in the mobile phones. It is used in railway networks. It is used in Aadhaar networks. It is used in timing services. It is used in e-tolling and many other activities in ground. For example, truck movements, etc. In mobile phones, it has not come because of one technology issue, and that we are solving by adding a new frequency called L1 band. Today you heard about ham radio talking about some megahertz. Similarly, there is some frequency which we need to use. Unless that is there, it will not come in mobile phone. We have already launched one satellite in L1 band, and we are planning to launch more numbers. Then it will be all in your mobile phones in another 2 years. I can guarantee you our NavIC will be operating your mobile phones, road traffic, and other networks. So this is another big area we are working on. Next. We work with the hospitals for giving education services and telemedicine and tele-education is a very important network, but not in cities, but it is more in the remote areas, hills, unconnected places. Our satellites are helping everyone to do education. Today I have seen some of the connectivity that you are having today through BSNL. So congratulations to BSNL for giving connectivity to all your schools, providing your network of connectivity and educational services. Like that, ISRO is doing services to areas in field areas and remote areas. It's a very important area which you are working. Next. We also give search and rescue. Suppose you go to a hill for trekking and get lost, how to come back. If you go to sea and get lost, if you go to a forest and then get lost, you can use our satellite services to track you and find out in case you are lost. So we have a service running. And recently we have been adjudged as the best service providing country in the whole of this region, and we got an award also. and our satellites are used for this. And you can tell you that it's a free service which you are giving the entire globe network. It's we are part of that whole global network for providing these services. After the service has come, we have saved almost 2,000 plus lives from accidents as we saved. It's a great service that we are doing. We also give services to warn you about cyclones. No? Have you seen newspapers, television, these pictures? You know where from it comes? It comes from our satellite called INSATs. We have 3 INSATs now. We recently launched an INSAT 3D, which is very important for our climate and weather prediction. Next one. We also predict landslides, and this is the Wayanad landslide recently happened. You can take images, beautiful images, but unfortunately this was an accident case. But then we should also help people in case of accidents, how to reconstruct, how to build, support them in case of reconstruction, etc. And you look at this map, India, so many places are affected by landslides, and this is the landslide atlas of the country. So many hills and slopes have a danger of getting landslides, and we give warning to every state and services. Even for Karnataka, we have a regional center which is helping them to work on similar services. Next. We give a lot of applications to help people. Have you any time seen this application called Bhuvan? You can see internet now, all of you can see internet. So one day you should type this https://bhuvan.nrc.gov.in and see what it is. And it gives you a lot of data of India-specific data from satellites. And you can browse it, you can go to state-specific, you can look at Karnataka and see what all data that is available. Karnataka, each of the states, we give huge data related to agriculture, related to water, your cartography, hills, post offices. If you just want to know where is a post office, you can find out using this. You can find out schools. You can find out the land usage history. You can look at forest fire, floods. Every data is available in this site. Some of you should search and find out. And I can tell you, if you are familiar with this, you can actually create a lot of value out of it for your project work in schools. Teachers, please use it so that students become familiar with it. Next. And we give data on climate, all our daily predictions of rain, weather, climate change, etc. We give every data using satellite. We have almost 16 to 17 parameters which is applied every day to the Indian Meteorology Department from satellites. Next. And I want to tell you a few more points about this, and then we'll discuss some questions, etc. Recently, we have announced a new program, Vision 2047. To land an Indian on the moon by 2040. Okay? And not only that, we should build our own space station called Bharatiyandrisha Station. This is also announced. And for doing it, we are developing a new rocket called NGLV. And we are also going to have missions to go to moon again and again. We have already announced a mission to moon called Chandrayaan-4, where we go to moon, drill and take samples, and come back to Earth and deliver it to us for understanding scientific studies on them. And all these are announced, and we will be working on each of them, so I will not spend time on it because we have a lot of time to discuss for next. And this is the part of the space station we are developing. It will have 5 modules, and we have completed all the design of it. And the first module will be launched in 2028. Already funding has come, and the rocket is getting ready with the human spaceflight mission, and we are going to extend this capability to launch space station. Finally, Indians will be going regularly. And anyone know how many of you are ready to become an astronaut? Anyone interested? No, somebody, all of you are doubting. How many of you are ready? At least I have some names. And what way you want to become? Like Sunita Williams? Want to become an astronaut and do a scientist astronaut or just a pilot? Any idea? Pilot. You want to pilot this? Oh, great. But now we have 4 astronauts today. India, after the previous astronaut, now we are training 4 of them, which will go in Gaganyaan. But I am telling you, in the future, young people like from you should come to the astronaut corps to do scientific research. Today, the pilots are coming from Air Force. They are Air Force aircraft pilots are the only astronauts. But sometime later, I am sure people in scientific departments, teachers, even common people will be able to fly to space. At that time, you can all aspire to become a scientist to go to International Space Station, Bharatiyandrisha Station, and work there. So the work there are related to many scientific fields like agriculture, medicine, material science. In those areas there is research happening in this laboratory. That's my hope and dream, one day it will happen. Okay, go next. And this is the Chandrayaan 4. We are building to go to moon and come back. Next one. And I want to tell you people, especially young people who are interested in working in space. Today we have a lot of startups in space. Even in Bangalore itself, there are about 10-15 startups in space companies. Not only everyone can get job, not only in ISRO but also in startups. They are developing rockets, they are developing satellites, they are developing applications. So today in India there are 250 plus startups working in space, and we have opened our space department to all of you to come and work. Earlier we were very close, we were not telling anyone don't come here, we have closed doors, but we are fully open now. If young people have ideas, you can come, you can see our laboratory and understand. And if you want to work in scientific area in the future, you should all come and work with space department. And we want to tell you that it's our interest that our technology which you are developing is available to you for developing it and using it. Next one. Next, I will skip this. Next. Okay, so I will conclude my talk saying that the technologies that ISRO has developed has been going to industries, and it is also available to young people who are interested to develop startups or companies in the future. Today you are in schools, you will not understand what is involved in building startups or companies, but once you go to some professional education, I can tell you, you will get to know how to build companies, how to build startups, and many of the big companies you see here are built by normal people like you. And I want to see that this happen maybe in space sector, and I can tell you Karnataka is one of the leading in aerospace area, and you should all come up with some good ideas to build a space competition in India, and it should happen here. So we will be mostly supporting you in many areas of technology transfers and hand-holding and helping through the ISRO's capabilities. So let me conclude, thank you, and also wish that one day you will be all traveling like this to space in the Gaganyaan rocket, where the LVM-3 will take you to orbit. So you can see it separating, and the crew module going out to space. The astronauts today have done their job, and they are trying to come back by deboosting and come and land in the Indian Ocean. And of course, we need to ensure that we will be picked up safely, because ocean is such a vast area, and our Air Force and Navy people are working with us to ensure they will be there with us to work on this complex mission. And I would like to thank you at this point and then say, so we are all inspired by young people, especially who show so much of interest to work in space. So I am at all ears to listen to your question and give clarifications wherever it is needed, as much as our people on the dais permit me. Okay. So now let me ask your questions.
Thank you, sir, for that wonderful presentation, and to do this important job of moderating this program and asking questions on behalf of all of us, and thereafter to all the students, we would like to invite Dr. Guru Prasad, Director of the Jawaharlal Nehru Planetarium, and to moderate this program.
ವಿದ್ಯಾರ್ಥಿಗಳೇ ಸಂವಾದವನ್ನು ನಡೆಸಿಕೊಳ್ಳಲಿಕ್ಕೆ ಡಾಕ್ಟರ್ ಗುರುಪ್ರಸಾದ್ ಅವರು ಬಂದಿದ್ದಾರೆ. ಈಗಾಗಲೇ ಸೋಮನಾಥ್ ಸರ್ ಹೇಳಿದ ಹಾಗೆ ಇಸ್ರೋದ ಸಾಧನೆಗಳು ಮತ್ತು ಬಾಹ್ಯಾಕಾಶ ಜಗತ್ತಿನಲ್ಲಿ ಮುಂದಿನ ಯೋಜನೆಗಳು ಯಾವ ಸಾಧನೆಯನ್ನ ರೂಪಿಸ್ತಾ ಇದ್ದಾರೆ ಇದೆಲ್ಲವನ್ನ ತಿಳಿಸಿದ್ದಾರೆ. ಅದರ ಕುರಿತಾಗಿ ಯಾವುದೇ ಪ್ರಶ್ನೆಗಳಿದ್ರು, ವೈಜ್ಞಾನಿಕವಾದ ಪ್ರಶ್ನೆಗಳಿದ್ರು, ಅದನ್ನು ನೀವು ನೇರವಾಗಿ ಕೇಳಬಹುದಾಗಿದೆ.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ವೇದಿಕೆ ಮೇಲೆ ಇರುವಂತಹ ಮಂತ್ರಿಗಳಾದ ಮಹಾದೇವಪ್ಪನವರೇ, ಹಿರಿಯರಾದ ಮಂತ್ರಿಗಳಾದ ಶ್ರೀ ಬೋಸರಾಜು ಅವರೇ, ಸಮ್ಮುಖದಲ್ಲಿ ನಾನು ಇರೋದೇ ನನ್ನ ಪುಣ್ಯ ಅನಿಸುತ್ತೆ. ಆಮೇಲೆ ಸೋಮನಾಥ್ ಅವರು ಇದ್ದಾರೆ. ಸೋಮನಾಥ್ ಅವರ ಜೊತೆ ನಾನು ಕೂತ್ಕೊಳ್ಳೋದು ನನಗೂ ತುಂಬ ಸಂತೋಷವನ್ನು ಉಂಟು ಮಾಡಿದೆ. ಜೊತೆಗೆ ಎಲ್ಲ ಗಣ್ಯರಿದ್ದಾರೆ. ಇವಾಗ ಇಷ್ಟು ಹೊತ್ತಿನವರೆಗೂ ಸೋಮನಾಥ್ ಅವರು ಭಾರತೀಯ ಅಂತರಿಕ್ಷ ಕಾರ್ಯಕ್ರಮದ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ರು. ಅದರ ಬಗ್ಗೆ ಇವಾಗ ಪ್ರಶ್ನೆಗಳು ಏನಿದೆಯೋ ಅದನ್ನು ಇಂಗ್ಲೀಷ್ನಲ್ಲಿ ಬರುತ್ತೆ. ಅದನ್ನು ಒಂದೊಂದು ಪ್ರಶ್ನೆಗಳು ಇಲ್ಲಿ ಸಭ್ಯರು ಕೂತಿರೋರಿಗೆ ನೀವು ಕೇಳ್ಬೋದು, ಅವರಿಗೆ ನೀಡಲಾಗುತ್ತೆ. ಆಮೇಲೆ ಮತ್ತೊಂದು ಬೇರೆ ಕಡೆಯಿಂದ ಅಂದರೆ ಕರ್ನಾಟಕದ ಈ ಕಡೆಯಿಂದ ಶಿಕ್ಷಕರು ಹಾಗೂ ವಿದ್ಯಾರ್ಥಿಗಳು ಪ್ರಶ್ನೆ ಕೇಳ್ತಾರೆ. ಇಲ್ಲಿ ಒಂದೇ ಒಂದು ವಿಚಾರ ಹೇಳ್ತೀನಿ. ಮುಂಚೆ ನಾನು ರಮಣನ ಕರೀಬೇಕು, ಅದಕ್ಕೂ ಮುಂಚೆ ಒಂದೇ ಒಂದು ತಮಾಷೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಸೋಮನಾಥ್ ಅವರು ರಾಕೆಟ್ನ ಚಿಕ್ಕ ರಾಕೆಟ್ನ ಲಾಂಚ್ ಮಾಡಿಕೊಂಡು ಅದರಲ್ಲಿ ತಾಂತ್ರಿಕ ತೊಂದರೆ ಇಲ್ಲ, ಅದು ಉಡಾವಣೆ ಆಗಲಿಲ್ಲ. ಆದರೆ ಇದುವರೆಗೂ 8 ಬಾರಿ ಅವರು ನೇತೃತ್ವವನ್ನು ವಹಿಸಿದಂತಹ NavIC ಎನ್ನುವ ರಾಕೆಟ್ ಒಂದು ಸಲ ಮೇಲೋಗಲು ತೊಂದರೆ ಆಗಿಲ್ಲ.
Thanks a lot for your approval, and very soon we will make sure that our students are listening both Hostel Center and Sri Deportment Center. And I also have one more request, sir, on behalf of all the students. We wanted to give you a memento that you will have it in your office. So what we have decided to give you is a painting, very unique painting, where we wanted to put an Indian farmer into the space by ISRO, rather than ISRO. Thank you, sir.
Thank you very much. Now we will have Q&A, interaction with ISRO Chairman. For this, the very first question comes from Mubashir Dambal. She is a science teacher from Ghana. Let the question be asked by the teacher, please.
Good afternoon. I respect all the teachers. I am Kushi, a science teacher, and I am a student from Residencial Schools, wherever I am interested. My question is, how communication is useful for astronauts or space mission?
Radio is used for not only for space, it is used for communication across many domains. As you see, in space station specifically, they have so many. They have a direct line of sight communication with 2 microwave beams. So our antennas will receive directly using a transmitter on the craft. Or if they are not in direct line of sight, the signal will go to a satellite and you will go to a ground station and you can come back and receive it. So this is another mode of communication. Thirdly, if everything fails, then the only help will be possibly from HARM. So HARM has an advantage that it is failure proof, that nothing can cause harm to vanish. So that's why HARM is very important for natural disaster locations where communication networks fail. When terrestrial optical networks fail, even satellite networks fail, HARM can still provide communication to various other channels. So generally such missions, space missions, they keep a HARM radio also part of the craft, so that in case of any danger of other regular communication protocols failing, HARM will be possible to do that, because HARM is a low latency, low data rate communication network. Normally in satellites and many others, we have a high data rate, high throughput communication networks, which is prone for failure. So the real use of HARM is in case of contingency, in critical conditions, etc. Okay.
Thank you, sir.
Thank you.
Okay, sir. Thank you for the information.
ಬೇರೆಲ್ಲ ಸಂವಹನ ಮಾಧ್ಯಮಗಳು ತೊಂದರೆಗೊಳಪಟ್ಟಾಗ ಹ್ಯಾಮ್ ಮೂಲಕ ಅಂತರಿಕ್ಷದಿಂದ ನಾವು ಸಂವಹನ ನಡೆಸಬಹುದು ಅಂತ ಇಸ್ರೋ ಅಧ್ಯಕ್ಷರು ಹೇಳಿದ್ದಾರೆ. ಥ್ಯಾಂಕ್ ಯು ಸರ್. ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್, ದ ಸೆಕೆಂಡ್ ಒನ್ ಕಮ್ಸ್ ಫ್ರಮ್ ಸಾನಾ, ಫಸ್ಟ್ PUC, ಅಟಕಮಾರನಹಳ್ಳಿ, ಬ್ಯಾಂಗ್ಳೂರ್ ಅರ್ಬನ್. ಪ್ಲೀಸ್.
Yes, Sana.
Sana, please go ahead.
Good afternoon to everyone. I am Sana S. Hussain of class 1st PUC studying at Moraji Desai Residential PU College, Adaki-Maranalli, Bengaluru. Sir, I have a question to ask, that what inspired you to pursue a career in space? I repeat it, what inspired you to pursue a career in space?
Sana, I'll tell you a story. I was also a midday student. When I studied in school time, there was no electricity in my house. So in my 10th standard, I used to watch stars. So we will all lie on some coat outside the home and we'll be looking at the sky. At that time, there were a lot of stars. Today also there are there, but because of the pollution, you cannot see all of them. So I used to look at the stars along with my father. So my father used to tell, this is this star constellation, this is that star constellation. You know the constellation, what it is meaning by that? You can identify by the star constellation. My star is Uttarabhadra, so you can see Uttarabhadra star, that is They also can identify some planets, and that is Jupiter. And you can see the Mars, it is slightly red in color. And Jupiter is one of the very bright planet that you can see in the sky. And I will ask a question, oh, these stars are all blinking, why they are blinking? And you can also see them moving around with annual, every year when you look at it, they are not at the same place. Their size and constellation size is also changing. It's a very interesting thing. Then my father brought a book called Star Atlas. It was published by somebody. It is a small booklet. You can use it on January. If you look at the sky, it will look like this. In February, it will look like this. So you can actually use it to map the sky and understand. So it created some interest in me in school times. And I used to get small magazines, etc., where space was discussed. At that time, little bit about space and science was discussed. So as a village student, I was interested in it. So when I studied, I was a good student in school, okay? So I passed out very well in 10th standard. In fact, I used to be the topper in the state for science at that time. But then after I go into engineering, only my interest in ISRO and space work which we are doing, I came to know about it a little later, because at that time in the village, nobody knew about ISRO. In fact, none of my parents also had no idea about ISRO, okay? But then after I go to engineering, I came to understand there is a center nearby working in rocket design. So in engineering, I made sure I want to join there only. So I asked my teachers to teach me space related subjects, which was not there in the college. So some of the teachers came voluntarily, took the subject, they learned and taught us in the final year. Propulsion was taught by one of my teachers, so thanks to them. And because of that, I went for interview in ISRO and got selected, even before I passed out. So they took me when I was in my 7th semester. So, along with my classmates. So that's how I got into ISRO. So it was a passion to understand about ISRO and work in ISRO. Early in my life, that made me to go to that. And all of you can also do that. You don't have to be from the top-notch institution. Even from a regular, normal school, of course, you are having the privilege of studying in these residential schools. And I wish all of you will do great in your life. Thank you.
Thank you, sir.
Thank you, sir, for giving an ignition for our ignited man. Thank you, Valla.
Thank you.
ಯಾವ ರೀತಿ ಆಗಸವನ್ನು ವೀಕ್ಷಿಸುವ ಮೂಲಕ ಅವರಿಗೆ ಪ್ರೇರೇಪಣೆ ಆಯಿತು ಅನ್ನೋದನ್ನು ಹೇಳಿದರು. ಈಗಾಗಲೇ ರೆಸಿಡೆನ್ಷಿಯಲ್ ಕ್ರೈಸ್ ಶಾಲೆಗಳಲ್ಲಿ ಸನ್ಮಾನ್ಯ ಶ್ರೀ ಮಹಾದೇವಪ್ಪನವರು ಈ ರೀತಿ ಶಾಲೆಗಳನ್ನು ರಿಮೋಟ್ ಪ್ಲೇಸಸ್ ಅಲ್ಲಿ ತೆಗೆದಿದ್ದಾರೆ. ಅಲ್ಲಿ ಕೂಡ ನಕ್ಷತ್ರಗಳನ್ನ ನೋಡಬಹುದು. ಜೊತೆಗೆ ಬೋಸರಾಜು ಸರ್ ಟೆಲಿಸ್ಕೋಪ್ಗಳನ್ನು ಕೊಡ್ತಾ ಇದ್ದಾರೆ. ಅವುಗಳನ್ನ ಉಪಯೋಗಿಸಿಕೊಂಡು ವಿದ್ಯಾರ್ಥಿಗಳು ಇನ್ನೂ ಹೆಚ್ಚಿನ ಪ್ರೇರೇಪಣೆ ಪಡೆಯಬಹುದು. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು.
ಮುಂದಿನ ಪ್ರಶ್ನೆ ಲಕ್ಷ್ಮೀ ಪ್ರಿಯಾ, ಇದು ರಾಮನಗರದಿಂದ ಬರ್ತಾ ಇದೆ ಪ್ರಶ್ನೆ. ಲಕ್ಷ್ಮೀ ಪ್ರಿಯಾ ಅವರು ಇದು ಝೂಮ್ ಕಾಲ್ ಮೂಲಕ ಬರಬೇಕು ಈ ಪ್ರಶ್ನೆ.
Yes, Lakshmi Priya, come on.
Good afternoon, sir.
You are here.
I am Lakshmi Priya, studying in first PUC at Morarji Desai Upgraded Residential School, Dodbadgere. Respected sir, I would like to ask you a question. Could you please share some of the most challenging moments that you have faced in your space career, and how would you overcome them?
No, that will require a lot of time, my dear, to speak about. So, because here there is now a lot of students are waiting for questions. My experiences are with story. I have to write a biography after that. But then, most importantly, I will tell you a few of them. Some of them are failures. I want to tell you.
Hello, Aramadi.
Maybe you will understand. Have you failed in the examination till now?
No, sir.
You are all successful, no?
Yes, sir.
But you think about it. You are failing in one test. Like I failed in one rocket launch, and the rocket don't go all right, and you are responsible for the rocket. Just imagine. No, the failures are very difficult. And I launched the failure of the first PSLV. The previous part of the PSLV launching team, and the very first PSLV when it was launched, I was not the project director. I was only a young engineer. I worked only 10 years there. You would have heard about a Kalam story, but that story I don't have. I have a different story. So I was only a young engineer. Only worked in 10 years, and we are ready for the launch. And I was working in many parts of the rocket as engineer. And the first launch just failed. But then, it is such a sad part for all of us. And the most important thing which we survived is after we came back, studied what went wrong, and then immediately we worked on the second launch, and that was great success. So I still remember the sadness and the sorrow each one of us had on the day that it failed, and how we worked very hard in the next 10 months to make the launch all right and launch it successfully. So this is one of the important story, I believe, and I learned a lot of things in that failure. My seniors, today many of them became chairman of the project director of the PSLU at that time was Madhavan, who became the chairman of ISRO later. He was my immediate boss, and many others. So this is one story. But then the most important story I want to tell you in life is not of failure, about the rocket which I was a project director. I was a project director for the rocket that you just saw taking off now, the LVM-3. So when that project was about to be made, it was conceived, the organization made a committee to make, I was the person to write the project report, the number secretary of the committee to write the project report. That was in 2000. And we made a project report, that was 2,500 crores project report. And in that the rocket was there. Rocket was only a small drawing in an A4 sheet. A small drawing which I made it in computer and put it in that report. But later, after 12 years, this rocket was ready. And that day I was a project director. You can imagine. So you wrote a project report with a small drawing one day, and after 12 years, that small drawing has become a huge rocket. And it's huge because its mass is 640 tons, its size is 4 meters in diameter, and a massive one. And as a person working in ISRO, what more you can demand? Your dream of building a rocket from a paper to reality has come in your life, in front of you. It's such a most pleasurable moment in anyone's life. Working on something and seeing it really taking shape. And I can tell you that fulfilled my heart more than anything else in my life. Thank you.
ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಇಸ್ರೋ ಅಂತಹ ಒಂದು ಅದ್ಭುತವಾದ ಸಂಸ್ಥೆಯಲ್ಲಿ ಯಾವ ವಿಧವಾದ ಅವಕಾಶಗಳು ಅವ್ರಿಗೆ ಸಿಕ್ತು ಅನ್ನೋದನ್ನು ಬಹಳ ಚೆನ್ನಾಗಿ ಹೇಳಿದ್ರು. ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಇವಾಗ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ವಿಲ್ ಕಮ್ ಫ್ರಮ್ ಚೇತನಾ ಜೆ ಆಫ್ 9th standard, who is here. Chetana J of 9th standard.
Good morning, sir.
Good morning.
My name is Chetana. I am studying 9th standard, Morarji Desai Residential School, Chabrajpete, Bangalore. My question is about your life. What key moment shaped your journey becoming ISRO chairman?
Again, same, it's all very long stories to make short, sir. Not to take too much of time. See, I can tell you, it is the people who influence you. Teachers, for example, in schools, they are the most influential people in your life. I had so fantastic people in school. My physics teacher was very, very good. Rajan Babu, I still remember his name, who was teaching me physics in 10th standard. He will not teach anything. He will not teach anything from the textbook. He will only tell me stories. Not me alone, entire class, he will tell stories of various kinds, science-related stories. But he will not cover the syllabus. And he will tell, okay, oh, now exams have come, you have to study syllabus, otherwise you don't get marks. So I'll teach you some syllabus, and he will complete about 4 or 5 chapters in 1 hour. And you read and find out. No issue. This is all simple thing only, you can read. But I can tell you, guarantee you, all of us got excellent mark in the physics from the school. And I can, in my village school, from that class, at least 4 of us became engineers. And there was never before anyone became engineer from that school. And another teacher, mathematics teacher, Mr. Paul, he will come and tell us, see, I am teaching you these theorems. But never believe me, because mathematics teacher is telling you, you should not believe it. You should find out whether what I am telling is correct or not. So you should go and do experiments to find out whether what I am telling is correct or not. So how many teachers have the courage to tell that today? So I want to tell you people, if any one of your students want to become great, only option is your teachers should become equally great. Okay? And this has to happen in schools. And they have to motivate them to question, ask questions, to enquire themselves and find out their own potential. And I want to thank many of the teachers. There are plenty of teachers. My class teacher, Bhagavati, who was in 10th standard, who wanted me to become an engineer, even in 10th standard. He gave me an IIT entrance textbook, and I had never heard about IIT at that time. And I met her, even when she passed away at an old age just 2 years back. I was always meeting my class teacher and taking her blessings in my life every time. So take your blessings from your teachers all throughout your life. Okay? You will be really great.
Thank you, sir, for your inspiring words.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ವಾಟ್ ಇನ್ಸ್ಪೈರಿಂಗ್ ವರ್ಡ್ಸ್. ಗುರುವಾದವರು ಯಾವ ರೀತಿ ಶಿಷ್ಯನನ್ನು ಬೆಳೆಸ್ತಾನೆ ಅನ್ನೋದಕ್ಕೆ ಬಹಳ ಚೆನ್ನಾಗಿ ಹೇಳಿದ್ದಾರೆ ಸರ್. ಇವಾಗ ಮತ್ತೊಂದು ಪ್ರಶ್ನೆ ಕಾರ್ತಿಕ್ ಅವರಿಂದ. ಮಿಸ್ಟರ್ ಕಾರ್ತಿಕ್ ಇಲ್ಲೇ ಇದ್ದಾರೆ, ದಯಮಾಡಿ ಮಿಸ್ಟರ್ ಕಾರ್ತಿಕ್, can you ask the question?
Yes, Karthik.
Karthik from Bangalore.
Hey, nobody wants to know about space technology. Aliens. Hey, what is
Hello sir.
All questions are about me. Huh?
Yeah.
Okay. Where is Karthik? Yes.
Hello sir, namaste.
Namaste.
I am Karthik from Sri Daksha Academy. My question is, how is ISRO utilizing satellite technologies to support rural development in India?
There are a lot of things we do. For example, rural development is happening through various government machinery. One of them is understanding what is the need of the rural ecosystem. You know, rural economy is driven by mostly agriculture. So we have to help agriculture, water, and also the rural planning service. For example, roads, schools building, and many other infrastructure support. So what we do is we use satellites to help the planners on the ground to plan all of this. For example, if you want to build a good road, whether what is the right place to build a road. If you want to build a school, what is the best place to build a school compared with the location and travel and other requirements. How to look at the agricultural ecosystem there. What is the right type of crops that you want to place. So we do crop advisory. We work with agriculture ministry and help them to do the agriculture advisory. We do crop forecasting to help to find out what is the type of yield that will happen from land. So as to plan for import, export and get the best price for the farmers. We help in terms of the prediction of rain and also look at the ground and tell you that yes, there is a soil moisture content, yes, you should have more water at this time. You should have fertilizer efficiencies that you can advise being a fertilizer advisory. So there are, and if you have a disease, pesticide, pest infestation is happening, you can say there is pest happening now, you better look at it. No, like that, you can, and there are other technologies in the whole platform. Even a panchayat can decide on planning. So we are given a tool, how to build a road, how to build a school, how to build a hospital. There are applications in the whole. And local panchayat advisory committees can help in terms of planning. So there are many such tools available. Unfortunately, the issue to raise, many of them are not aware of this. So our one goal is how to help people understand using space technology. There are plenty of things, but what we have done is only examples and demonstrations at some villages and some villages. But widespread use of this will not become really happen. But we have a lot of administrative departments, including government of India, state governments, maybe as a part of this. But a lot of things are happening, and we want to make sure private companies come in and make use of this support services. Okay. So this is the goal. Okay.
Thank you. Thank you very much. ಭಾರತೀಯ ಅಂತರಿಕ್ಷ ಕಾರ್ಯಕ್ರಮ ಯಾವ ರೀತಿ ಸಮಾಜಮುಖಿಯಾಗಿದೆ ಅನ್ನೋದನ್ನು ವಿವರಿಸಿದ್ದಾರೆ. ಇವಾಗ ಮುಂದಿನ ಪ್ರಶ್ನೆ ಝೂಮ್ ತೆಗೆದುಕೊಳ್ಳೋಣ. ಪ್ರೇಮ ಆಫ್ 9th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಬೆಂಗಳೂರು ಅರ್ಬನ್ನಿಂದ ಝೂಮ್. ಪ್ರೇಮ, ದಯಮಾಡಿ ಪ್ರಶ್ನೆ ಕೇಳಿ.
Yes, Prema.
Good afternoon, sir. Good afternoon. My name is Prema from 9th standard studying in Putturu Rani Channamma Residential School. Respected sir, I would like to ask you a question. How space technology is improving our daily life? Can you give examples?
One example I will give you. If it is helpfully possible, you can understand. You know, when fishermen go out to go fishing, how do they go? They start the boat every day morning and go out in the sea, spread their net and catch fish. Correct? So deep in the sea, they have to go few kilometers, and sometimes you will find there is no fish, and sometimes you will find there is fish. And there are some local knowledge. Okay, if you go cloud, if you get the rain, if you go here, possibly you will get better fish. So using satellite data, you can help them where you should actually go today morning to get the best catch of fish. Or there is fish is not there, better not to go. Correct? So we have something called fish advisory. So what we do is we have a satellite called OceanSat, and using the OceanSat, if we image the sea, we can find out whether fish is there or not there. And you cannot actually see the fish, but you can actually see the ocean color. That means whether the planktons are there, We can look at the temperature. If the temperature is in this range only, likely to be a plankton there and fish there. And then you look at the sea state, we call it sea state 1, 2, 3. It is a very agitated sea, there will be no fish and it is not good for going to fishing there. So looking at various parameters, we give an advisory, okay, this location in the sea is likely to have fish today morning. And this data is available through an institution in Hyderabad called Kreis, and this is published in the coast of eastern coast and the western coast and available to fish harbor locations. And fishermen, if they are taking this data and going out to fish, their effort to catch fish will be substantially reduced. So we have made an estimate using this service, the diesel charges which are spent on each of the boat can be brought down substantially. You understand? This is one example of a benefit that can be done from space. Okay?
Thank you, sir. Okay. ಭಾರತೀಯ ಅಂತರಿಕ್ಷ ಕಾರ್ಯಕ್ರಮ ಯಾವ ರೀತಿ ಸಾಮಾನ್ಯ ಮನುಷ್ಯನೊಬ್ಬನ ಜೀವನದ ಮೇಲೆ ಪರಿಣಾಮ ಬೀರ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನು ಸರ್ ಹೇಳಿದ್ದಾರೆ. ಇವಾಗ ಪ್ರಾರ್ಥನಾ ಅವರಿಂದ ಪ್ರಶ್ನೆ ತಗೊಳ್ಳೋಣ. MDRS ಹಾಸನ್ ಪ್ರಾರ್ಥನಾ ಅವರು.
Okay.
Good afternoon, sir. Good afternoon, sir. I am Prathana, studying in 10th standard at MDRS. Good afternoon, sir. I am Prathana, studying in 10th standard MDRS category of Hassan district. My question is, the space exploration programs that inspires other than Aditya Evan to the future citizens of the great India.
Prathana, I didn't get the question clearly, but you are talking about Aditya Evan and space exploration, correct?
Yes, sir.
Okay. Aditya Evan was a mission to study sun. Okay. And we have many other exploration missions like going to moon, Chandrayaan series, studying Mars orbital mission. We did another mission, exploration mission called XPOSAT, X-ray polarimeter satellite, to study black holes and its origin. Okay, and we have now planning to send a mission to Venus. You know Venus?
Yes, sir.
Okay. What do you call Venus in Kannada? Ashokra, correct. So, okay, so we are planning a mission to Venus. We have plans to study asteroids, and possibly one day we will also send craft beyond our solar system. There is only one satellite has gone beyond solar system, American satellite. Do you know that?
Yes, sir.
Okay. So, exploration is very important area that we need to work. So we need to study the origin of the universe and also look at how other planets and areas are there, and something about exoplanets. There is a mission. Yeah, I can see you. Speaking of mind,
ಮುಂದಿನ ಒಂದು ಕೇಂದ್ರಕ್ಕೆ ಹೋಗೋಣ. ಈಗ ವಾಪಸ್ ಇವಾಗ ರಕ್ಷಾ ಬಿಸಿ ರಾಮನಗರ ಇಲ್ಲೇ ಇದೆ. ರಕ್ಷಾ ಬಿಸಿ ದಯಮಾಡಿ ಪ್ರಶ್ನೆ ಹೇಳಿ. ರಕ್ಷಾ ಬಿಸಿ.
Good afternoon, sir.
Ah,
My name is Rashna BC. I am studying in 8th standard and I am from Major-Manivannan Residential School, Mayapalli, Ramadan. So my question is, what is your vision for India's future in space exploration, and what role does India play in the international space collaboration over next few decades?
excellent question, Maria. I think there's a lot of things you will speak about it. One of the goals we have is, I talked about the story of India in the 1960s today. We achieved some great accomplishment. The space technology we have done today is really world class. Only issue we have today is that we are operations are less in the scale. That means our money that is in space economy that we are looking is very small. In actual numbers, I don't know how you will understand. Our investment today, budget and allocation is typically around 12,000 crores per year. For a country like India, this is a very small money. Now, our contribution to the global space economy, which is something we value around $5 billion. It's a huge money, including managed by $5 billion. In that, our contribution is only 2%. Okay? So, in the whole world, we are a very strong nation. Our contribution to space economy is only small. That means we need to scale up. We are working really in scale. We are not more industry working in space, and our operations are in that field participation. So one of the missions we have today is to increase the scale of operation. So our
full ಓಡಾಡ್ತಿರೋದಕ್ಕೆ ಕ್ಯಾಮ್ರಾ ವಿಲ್ ಗಿವ್ ದ ಇನ್ಪುಟ್ ಓಕೆ ಬೇಕಾದ್ರೆ ಫುಲ್ ಯಾರು ಕೊಡ್ತಾರೆ ನಮಗೆ ಕಳಿಸ್ಕೊಡ್ತೀನಿ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಕಳಿಸ್ಕೊಡ್ತೀನಿ ಲಿಂಕ್ ಅನ್ನು
So we have a great plan. But to do that, it cannot be done forward. It has to be done by organized plan. So one of the missions that I have is to make private companies work on space and create businesses around space economy. Going with more, I don't know whether there is a business here. But building space station has a business potential. Because we can work on agriculture, civil electronics, bioengineering, we can work on medicine businesses, we can work on material modeling and material design. So all of this will be to industries, engineering, and then produce a brand out of it. So we are also looking at moving our rocket production and providing global space launch support. And we have already started the rocket in India. And people understand that building satellites in India because the building in India is going to be very low also. Our Tanzania or the lowest source of rocket is the satellite that they build. So we are getting world leading a government building company building satellites here. So many companies have started discussing. In fact, there's in Europe and America have started completely set up their facilities for our and some companies to create businesses in satellite building, communication services, so this is one of the important goals that I fix. So why I can do all of this is we have to really scale up our space technology and vision for the future. Money is very important. And this kind of something generated through appropriate business development. We can provide business. So this is the primary focus today. After having established that capability, now we will see moving to industries and doing business. Okay? I hope you understand.
They had studied elaborately about the movement of faraway planets. So today we have many modern equipment like telescope and all. My question is, without these gadgets, how could our ancestors study about celestial bodies?
Great question. Okay. See, telescopes came much later. The present idea of observing through optical telescopes came much later in Europe. In India, telescopes was not there. Even those astronomers, they found out through naked eye observations. So I know many of them, some of those great scientists spent years together looking at the sky. I was reading about one of the great mathematicians who kept catalogs of stars. So in one of the questions I told you, evenings I used to lie down and look at the sky. You can also do that. If you lie down and look at the sky every day, a few hours, can you spend that much time? You can't, because you are a student now. But some people have dedicated their life like that. Those people who are the astronomers at that time, they spend their life looking at the sky continuously, years together, lie down, mark on no leaves and things like that. And they made conclusions of the observations. And those observations are led to those findings, which some of them are based on logical thinking. See, many of them, for example, Newton's law came out of that, what? I don't know. He came out of his own thinking. Okay, but some of those scientific findings at that point in time were philosophical thoughts, some of them are logical thinking, and many of them were based on observational astronomy. But unfortunately, since instruments were not there, they were not going beyond it. They were thinking, the Earth is the center of the universe, and stars are moving around. They had no idea about the current idea about the galaxies. No, you don't know, there are billions of galaxies today. They were not knowing that much. Today we know the way in which galaxies rotate, the origin of the universe, the Big Bang, they were not aware of it. So many things they were not aware of, but they were aware of many other things which are primarily coming out of observation. For example, they understood about the day, they understood about the time scales, they understood about how day and night. I also built a small radio myself because we had a lot of kits of electronics. So I studied all of that and used it in my school time. So do you do some hobby of like that?
Yes, sir.
What is your hobby?
To be a doctor.
No, what is your hobby? What do you...
Drawing, dancing, singing.
Okay. What do you draw?
Sir, nothing much.
Yeah, but still something you draw, no? What are you going to do?
Sir, nature.
Nature. It's also good. So you are an observationist, no? You look at nature, you try to understand what it is, right?
Yes, sir.
Okay. So you look carefully. You know Darwin, have you heard about Darwin?
No, sir.
Darwin is a great scientist who studied nature by observation. He found out how species evolved by simply observing it. So if you are simply a painter of nature, still you can be a scientist. So a scientist is someone who spent time in observing. So I will tell you, my inspiration has been always my people, always who helped me, like my parents and my teachers. So there are many of them. So I can't name some names I told already, but I can tell you there are many teachers, and because of them I am here. So you have a favorite teacher in school?
Yes, sir.
One or more?
Sir, more.
Great.
Teachers.
Okay, great. So you go to them, seek help from them. Okay, they will help you what exactly are the course that you should take.
Yes,
Okay.
sir. Thank you, sir.
Thank you.
Thank you very much, sir. Now you have opportunity for people here, students here. Just 2 questions. Anybody? Raise your hands. Yeah. Okay. Kindly at the earliest, please.
Hello, I'm Kantraju. I would like to thank you all dignitaries. My question is, the ISRO has been set up a launch by 2029 Chandrayaan-4. Then, what are the objectives and significant milestones of the critical return by using 5 modules and by stacking and docking AM and AM, another PM and PM.
Okay, you asked a very complex question, but then I want to make it. You asked about Chandrayaan-4. Say her question is about Chandrayaan-4. So all the PM, DM, etc. are the names of the modules of Chandrayaan-4. Senior secretary and asking me this question. But unfortunately, you students only have done everything. So what I do is, I tell you, the purpose of Chandrayaan-4 is to understand how to go to moon and then come back. So we already so going to moon and activity we already answered. But to compare from moon to Earth is again a most difficult question because you have to start like a rocket on the moon. Moon is also like Earth and the planet. If you have to come back to Earth, you have to take off from surface of the moon like a rocket, go to the orbit of the moon, then fire the engine and come to Earth correctly. And none of us are there. Everything has to happen automatically using its own computer and system. And what is the software that will do all of this? So we want to study that one. So Chandrayaan-4 is essentially for that purpose. How to go to moon, land there, after that take off from there, go to orbit, dock it to what is there in orbit, then connect to it, come to Earth orbit, then finally rotate around Earth and re-enter like a reusable capsule. So it has 5 modules, and unfortunately we do not have a rocket today to send the whole of this mass to Moon. The mass we have computed is we need around 10 tons to go to Moon, around 9 to 10 tons to go to Moon. But our rocket capability is only 4 tons. So 4.5 tons. So what you have to do is you have to make 2 rockets. So first rocket will be ready today, we launch. After 2 weeks we launch one more satellite. Both will go to Earth orbit. So let me connect together in an orbit called Loki. Then after 60 unit of the diagram, we go to Moon. So you need so much of fuel, that's why so much of mass. Then on the way, the fuel will be over, so one more will survive and follow. It will again pass continuous journey, will reach Moon. Then land on the Moon, take off with the engine up there, talking on the Moon.
ಕೊಟ್ಟಿದ್ದಾರೆ ಒಂದು ಮೈಕ್ ಇದೆ ಮೈಕ್ ಇದೆ
So we have multiple walking and multiple engines. So it's a complex system. So our goal is to achieve it will be. Okay. Thank you very much. Yes, Dr. Master, please. Louder. Use the mic.
ಹೇಳಿ ಸರ್ ಹೇಳಿ ಹೇಳಿ ಸರ್ ಹೇಳಿ ಸರ್ ಹೇಳಿ
My position on studying PhD school. So my question is, there are so many countries competing to go to space. Then how can we make sure that India is the one leading, and how can we manage to research all of not only just our solar system but also the universe?
Okay, I didn't make your question entirely. So you said that there are many nations going to space, and how you really maintain the supremacy of the dominance of India under God, or something like that. Okay, so one thing I have to tell you that we do not want to be dominating anyone or being supreme. That is not the goal of India. Okay? Our goal is to serve the country, to serve our purpose. So we will ask you what is the purpose. One, we should be independent. Now, nobody should be able to stop us from doing what we want to do. That is the first thing. So we must have knowledge, we must have skill, we must have industries, we must have resources to do what we want to do. That is really rockets, really satellites, and all these things will be possible using our own resources. Resources include money, materials, knowledge, and power. So we have to create all of this good stuff. Industries are to be created, knowledge is to be created. Now, critical materials are required to run, govern the building of the city here. So we have worked on this for the last 4 years, but still there are issues like electronics. We are still working on electronics. We are able to still some specific materials from other countries, and how to overcome this is next challenge. Second is all about economy. India has enough money to do this. Going to Moon and coming back is very costly. In the 1960s, it took away almost 30% of the GDP to do that. Today, people hesitate to go to Moon because it is very costly. Even for us to say man to Moon, it will cost you $1.5 lakh. But there is a way India can think about it, because we are not a poor country. You can just $1.5 lakh in 20 years, that's no issue. But the bill also drops, and we are not a good thing for us. But still, there is a question in this country. How can you spend so much money when there are other things? So, you must create a business of it. And if there is no return of this money to many other channels, it will not produce. So, we have to make sure there is an outcome of all this money. So, this is a very important topic which we are looking at. How to create business, how to create an ecosystem to these other things. So, because you are very ill and I am talking about much about economics, it's very important for us. Why do we talk about technology? Also, how to be sustainable. Otherwise, what happens after doing something, government will really go on. So, if you want to sustain it, you must create a use of it. This is what study was done. All the money is from us invested in space technology, whether it's education society. We did a study. We found out for every 1 rupee investment, the return of investment is 2.5 times. So, we proved that our investment is so, we are actually one nation which is very dominant in this space. We want to be one part of others. We must have enough of knowledge. Our universal system should produce good data to serve the on-stage activity. And this will also contribute to global knowledge. For that, you don't want to come alone, you want to work in collaboration. That's why we are working with NASA, we are working with ISRO, we are working with Japan, many others. So the space is an area where we are all working on.
Thank you. I appreciate your participation. Move on further there.
Namaste, sir. My name is Rona, and I am from Residencial Schools in Bangalore. And my question is that, is there any mysteries on your experiences beyond the Milky Way galaxies?
Is there any?
Plans of discoveries beyond the Milky Way galaxies?
Discoveries beyond
Galaxies? No, I will do. Milky Way galaxies is a small place. So I am not going to Milky Way galaxy. Because you land into that like a very next galaxy. And like that, there are at least some 100 billion galaxies. So you can understand the size of the universe. The universe is such a huge human being cannot even imagine what size is. Your brain don't have the ability to even dream of this size. It's such a huge. And you are asking me whether you are comparing to your galaxy. Very good, I am happy about it. But to see that is very difficult. So, you know, you heard about the origin of the universe, the Big Bang theory. The Big Bang occurred 30.8 billion years back. And okay, after 30.8 billion years back, there was a Big Bang and the universe was created. And today, we have our capability even to look at 30.2 billion years back. We can actually see using the telescope which was recently launched by NASA. You know the telescope?
So I'm not sure of the name, but yeah.
It's called Wonder. Sorry, James Webb. I want to understand. This is James Webb telescope. Using the telescope, you can actually see up to 13.2 billion years deeper in the universe. That means you can actually see what happened 13.2 billion years back. At that point, what was the nature of the universe? Even before all this Earth and planet and Milky Way galaxies and all those galaxies came about, that's just a few billion years later, we can actually see. That means the light of that energy is still traveling through the universe, and if you look deeper and deeper and deeper into the universe using very powerful telescopes, you can actually see far beyond Milky Way galaxies. That's why we have so much knowledge about the universe, how it came about, how galaxies are being formed now, how galaxies are colliding. You know how Milky Way collided with the Andromeda zone? Are you aware of it? Yeah, please. How galaxies collide with Andromeda galaxy, but don't worry, much before that, you got generations to go, and none of us will be here by that time. So nothing will happen, but our galaxies collide with Andromeda galaxy, when computer simulations are there, showing these galaxies are colliding and stars changing. And you know, much before all that happens, our sun will also be there, Earth will go away. But one thing we should do, before all of this happens, we should somehow travel from Earth and go to another planet and be
launching a rocket. I mean,
the very planet called Constant is also C.
no, sir.
Constant is also because the scientist in Russia who proposed the rocket. The person for our rocket equation, but converting it into rockets.
And indeed it was an eye-opener for all of us. Space scientific contributions will go a long way in early sense of belonging to this wonderful nation. ಈಗಾಗಲೇ Dr.H.C.Mahadevappa ವೈಜ್ಞಾನಿಕ ಮನೋಭಾವವನ್ನು ಬೆಳೆಸಿಕೊಂಡಾಗ ಒಬ್ಬ ಸತ್ಸಂಗನಾಗಿ ಬೆಳೆಯೋದಕ್ಕೆ ಸಾಧ್ಯ. ಜೊತೆಗೆ ಮೌಲ್ಯಗಳನ್ನು ನಾವು ಡೆವಲಪ್ ಮಾಡಬಹುದು, ಮೂಢನಂಬಿಕೆಗಳನ್ನು ಪಕ್ಕಕ್ಕಿಟ್ಟು ಆ ನಿಟ್ಟಿನಲ್ಲಿ ನಾವೆಲ್ಲರೂ ಸಹ ಕೆಲಸ ಮಾಡೋಣ, ಆ ರೀತಿಯಾಗಿ ನಮ್ಮ ಜೀವನವನ್ನು ಬೆಳೆಸ್ಕೊಳ್ಳೋಣ ಅಂತ ಸಂದೇಶನ ಸೋಮನಾಥ್ ಅವರು
ಎಲ್ಲ ಮಕ್ಕಳಿಗೆ ವಂದನೆಗಳನ್ನ ಸಲ್ಲಿಸಿದ್ದಾರೆ.
ಈಗ ವಂದನಾರ್ಪಣೆಯ ಡಾಕ್ಟರ್ ಸಿ.ಪಿ. ದೇವರಾಜ್ ಜಾಯಿಂಟ್ ಡೈರೆಕ್ಟರ್ ವಂದನಾರ್ಪಣೆ. ಹಾಗೆಯೇ ವಂದನಾರ್ಪಣೆ ನಂತರ ಯಾರಾದರೂ ಸಹ ಸೀಟ್ನಲ್ಲಿ ಇರಬೇಕು. ಎರಡು ಇಂಪಾರ್ಟೆಂಟ್ ಅನೌನ್ಸ್ಮೆಂಟ್. ಒಂದು ಊಟದ ಬಗ್ಗೆ ಸಿಗ್ತಿರಲಿಲ್ಲ. ಸೆಕೆಂಡ್ ಒನ್ ನ್ಯಾಷನಲ್ ಆಂಥಮ್ ಪೊಲೀಸ್ ಅದನ್ನು ಪ್ಲೀಸ್ ಯೂನಿವರ್ಸಿಟಿ
ಕಡಲೊಳಗಿನ ಮುತ್ತಿನಂತೆ ಹೂವೊಳಗಿನ ಪರಿಮಳದಂತೆ, ಕಡಲೊಳಗಿನ ಮುತ್ತಿನಂತೆ ಹೂವೊಳಗಿನ ಪರಿಮಳದಂತೆ, ನಿಮ್ಮೊಂದಿಗೆ ನಾವಿರುವೆವು ಸದಾ, ನಿಮ್ಮೊಂದಿಗೆ ನಾವಿರುವೆವು